All right, let's start our week 2 with distance learning. This topic is all about describing polynomials, and we'll start with interval notation. And we did talk about interval notation earlier in the year, and many of you have been using that the whole year. If you haven't, just a quick review. If you look at the left column, this is all our inequality notation. On the right side is the interval notation. And just remember, if you do not have an equal to, then it is the parentheses, but whenever you have the equal to, you're using brackets. So here they are both not equal to, so they're both parentheses. Here we had two equal to's, so they were both brackets. Here we had a not equal to, so it's a parenthesis first, and then an equal to second, so it's a bracket second. And just remember, if this is saying x is less than 5, so the largest number it can be is 5, but not equal to it, so that's why we have 5 on the right side with the parenthesis, and then that means it's anything less than 5, and the smallest possible number there is negative infinity, so that's why the negative infinity is on the left. And again, you can never equal your infinities. On the other side, if we said x is greater than or equal to negative 3, that means negative 3 is the smallest it can be. It's equal to, so we have the bracket. And then anything greater than negative 3, the largest number is positive infinity. Again, you can never equal that. So you can see those. Just remember, the parentheses means not equal to, brackets means equal to, and we can never equal our infinities. So therefore, we're always using parentheses when dealing with positive and negative infinities. The next part just has some practice with our inequalities. And you can look at these. I solved these for x already. Everyone should be able to do that. Added 7 divided by 3, so x is less than 7. So if we were to write this with interval notation, it says x is less than 7, so 7 has to be the largest possible number. It's not equal to, so we use a parenthesis. And then the smallest possible number is negative infinity, and we can never equal that. So that's what that would look like. For the second one, we have x is greater than or equal to negative 5. So the smallest possible number is negative 5. It's equal to it, so I have a bracket. And then the largest number would be infinity. For the third one, I added 6 to all sides and then divided 2 to all sides. So it's saying that x is in between 5 and 8, including 5. And I'll do that up here. So 5 is the smallest. It is equal to, so I'd have the bracket. And then 8 is my largest. It's not equal to, so it would look like that. All right, next is our domain and range. Again, we have done domain and range pretty much all year, so this should not be too crazy for you. Quick review of that. Domain is left and right. It's your x values. So if we look at this first graph, it's going left forever, it's going right forever. So I'd have negative infinity to infinity, parentheses for both because you can never equal those infinities. Your range is your y values, which is down and up. So the smallest y value is how far down it goes, which it goes down forever to negative infinity. And then it goes up to right here, which is a y value of 4. And it does touch an equal 4, so we'd have a bracket with the 4. With the second one, domain is getting left to right. It goes left to negative 2. But notice the open dot, which means it's not equal to, so I have a parenthesis for negative 2. It goes right to positive 1 here, and it does have a closed dot there, so it would be touching 1, which is why I have a bracket. So negative 2 to 1, including 1, not including negative 2. And then our range, it goes down to negative 4. There's an open dot there, so that's why we have the parenthesis. And it goes up to 5 and includes every value in between there. So we have the 5 up there with the bracket. And then last but not least, we have the third one. It goes left to negative 3 and right forever to infinity. Includes every number in between. It's a closed dot, so we have the bracket. Never equals infinity, so we have the parenthesis. And then the range, it goes down to negative 4. Again, it's the y value of negative 4. And then it goes up to infinity. Alrighty, just remember the next topic now is going to be increasing, decreasing, and we did increasing and decreasing in the beginning of the year as well, but we did increasing and decreasing with pretty much just parabolas. So now we're going to be looking at increasing and decreasing with our polynomials that are increasing multiple times or decreasing multiple times. So just remember, when you read a graph, you always read left to right, just like a book, and our interval notation is how we're going to do this. So I'm going to start on the left, and if you notice, I am going downhill first. So that means I'm going to decrease beginning. So I'm going to go here where it says decreasing. You were always describing increasing, decreasing with your x values. So I'm going to put an x in there just to remind me that I'm using my x values. And then what x value does it start decreasing at? Well, there's an arrow here, so I could go all the way left forever. So it's decreasing at starting from negative infinity, and it stops decreasing right here. Again, I'm looking at my x value, so it stops decreasing at this x value of -3. And again, at the x value of -3, it's flat. It's not increasing nor decreasing, so that's why I have a parenthesis and not a bracket. And then right here, it starts to increase. So again, I'm looking at my x values. So at this, which is the x value of -3, and it increases to right here, which is an x value of 0. So the x value is from -3 to 0, it's increasing. Again, at -3 and 0, it is not increasing nor decreasing, so therefore I have parentheses for all that. It then decreases again. So the way I'm going to write this, I'm going to put this little u here, which means union. It's basically a mathematical symbol for and. So it's also going to decrease from the x value of 0 to right here, which is the x value of 2. So it decreases from here to here. If you're looking at the x values, 0 to 2. And again, we're always using those parentheses. And then it's going to increase, so I'm going to put that union again from the x values of 2 to infinity. All right, just a couple things. When a function is increasing, the graph goes up from left to right. So again, here's it's increasing, it's going up from left to right, up from left to right. And when it's decreasing, it goes down from left to right. So this is decreasing, going down from left to right, decreasing, going down from left to right. A couple more examples for us here. For this first one, it's increasing to start. So again, I'm always going to write my x here. Just note that I'm looking at my x values. And so right here it's increasing from negative infinity because it's going left forever. It stops increasing right here, which is at -3. Again, you're looking at the x values. Again, and we're always using parentheses because at those values it's not increasing nor decreasing. It then decreases between these two intervals, which is a -3 to a +3 in your x's. And then it increases again, so I put that union sign, 3 to infinity. All right. The bottom one is a little tricky. This one is actually increasing to start the whole way from negative infinity. And there's an asymptote here. There's a vertical asymptote here and another vertical asymptote right there. So it's increasing to +1. And then if you look down here, it's also going to increase again. So I'm going to put my union from 1 to 2. But again, at 1, the graph isn't touching 1 because of that asymptote. So we have to write it as two separate intervals. And then we're decreasing from 2 to 3. Again, we have that asymptote, so it's not touching 3. But then it's a decreasing again from 3 to infinity. All right, next is what we call relative or absolute extrema. Extrema just is the plural of extremes. So we're talking about minimums, maximums, and the word relative versus absolute. So let's go over our definitions before we label these. So first is an absolute maximum is the highest point on the entire graph. So nothing higher, kind of like Mount Everest is the highest mountain in the world, the highest point in the world. So therefore, there's nothing higher than it. You have local hills around you that are high, but not nearly as high as Mount Everest. So this is the Mount Everest of everything. So we look at our graph here, we're looking for the absolute highest point, nothing higher than that. So that's right here. So we call that the absolute max. We also have what's called the absolute minimum, which is the lowest point on the entire graph. So that's like your Death Valley if we're talking about the United States, the lowest point on our graph, nothing lower than it. So we have low spots in our area, but nothing lower than something like Death Valley. So right here's our low spot, nothing lower than that on the entire graph. So we call that the absolute minimum. And then we have relative maxes and relative mins. So a relative max is a high point at a particular part of the graph, which is like a peak. So it's like a mountain or a hill near you. It's the highest point. Top of the hill is the highest in that area, but it's not nearly the highest in the world. So we're looking for a high point in this area. So right here, this is going uphill and all of a sudden it goes downhill. So this is a high point, but it's not the highest on the entire graph. So this is a relative max. And also right here, since there's no arrow, this is also a relative max. It's not going on forever. And then our relative min is a low point at a particular part of the graph, which is like a valley. So a low point near your house is not the lowest part of the world, but it is a low part in relation to your house. So since this does not have an arrow, that is a low point for the graph. So it is a relative min. And this is also going down and comes back up. So right here is a relative min because it's a low point, but not the lowest for the whole graph. All right, so some practice. It says identify the ordered pairs. Change that x values to ordered pairs if you have not done so of any relative or absolute extrema. You're going to do number 2 on your own. I'm going to do number 1 with you guys. So our absolute max is the highest point on the entire graph. So right here is the highest point in the entire graph. So I'm going to label it as an ordered pair. The x is clearly 2. The y you just have to approximate. So it's definitely a little bit above 4. So I'd say maybe 4.2. The absolute minimum is the lowest point on the entire graph. Now if you notice, this is a low point, but these have arrows here. So it's going down forever. So there is no absolute minimum there. The relative max is a high point, but not the highest point. So this is increasing and then it comes decreasing. So this is a high point for that particular part of the graph. Again, we're going to label with the ordered pair. So it's -3 and -1. -3, -1. Then a relative min is a low point for the graph. So right here is a relative min. Be -1, roughly -3.5. Your y values don't have to be exactly the same as mine, but should be relatively close. All right, you're going to do number 2 on your own for practice. And we are going to move on to the next page. All right, so now what we're going to be doing is we're going to be given some information and we have to sketch a graph. So it says the function is continuous for all real numbers. So it means it's going to have arrows on both sides. It decreases between -3, -infinity, and -3. So what I'm going to do is I'm going to take and just make like a vertical dot line going through the x values of -3 because I know it's going to have to decrease before that. So I'm going to put decrease here. And then it says it increases between -3 and 0. So I'm going to put another dotted line between there. And I'll put increase here. It says note the function is increasing and decreasing at other spots as well. The function has a relative max at x equals 0. And I'll just make a little note, relative max, and an absolute minimum at x equals 1. So I'm going to put another dotted line here because I know something's got to go in here. It's an absolute min. All right. So when we go look at our graph, I'm just going to say it's decreasing. It says it's decreasing from -infinity to -3. It has to increase until we get to 0 because it needs to be a relative max. And then I have to have an absolute minimum next. So I'm going to go all the way down, make sure you're lower than this first one. And then since it's continuous for all real numbers, that means the domain's all real numbers, so I have to come back up. And just make sure you put arrows on each side. So it's decreasing from -infinity to -3. It increases from -3 to 0. Decreases from 0 to 1. has your lowest point right there, and then it increases from 1 to infinity. It says what happens at x equals -3? Well, we have a relative min there. It's a low point, but not the lowest. And then what happens to the function before x equals 1? So before it's increasing, after it is decreasing. And it says what happens to a function before and after a minimum and a maximum. So a maximum, before a maximum, it increases. So here's our max. It's increasing before the maximum, after it's decreasing. And in terms of the minimum, before the minimum, it decreases, and after it increases. And so we can just make a little sketch like this to show there's our max, increasing before, decreasing after. Here's our min, decreasing before, increasing after. All right, and then we'll do number 4 together. It says the function is continuous for all real numbers. Function has a relative maximum at x equals 2. So I'm going to put a dotted line and label that as relative max. Relative min at x equals -3. So relative min, and an absolute max, or absolute min at x equals 5. All right, so remember, it has, for a max, it has to increase and decrease. So this has to be the lowest. So I'm going to go down here like that. Something like this would work great. So the minimum, a relative min's here, so it's decreasing before, increasing after. A relative max here, increasing before, decreasing after. That has to be the lowest part on the whole graph, so it's decreasing before, increasing after. And since it's continuous for all real numbers, we put arrows on each side. All right, one more example here. This kind of combines everything together. So first it talks about domain and range. So domain is going from -infinity to 5. There's a closed dot, so we have the bracket there. The range is going down forever and up to 3. So from -infinity to 3. Your x-intercepts, we have to approximate. So right about here, about -2.80. Right here, 0, 0. 3.2, 0, and then 4.5, 0. And I have y-intercept right here of 0, 0. That's where it's crossing the y-axis. We have relative maxima. Maxima just means the plural for maximum. So there's 2 of them. So right here, it's a high point, but not the highest on the graph. So at -2, 2. Right here at 2, 1, a high point, but not the highest point. I have relative minima in this case as well, a low point but not the lowest on the graph. So right here is a relative min 0, 0, a low point right here 4, and I just wrote comma 0.8. So that 0.8 can be anything close to 0.8 would work. Absolute max and absolute min means the highest point. So the highest point on the graph is right here at 5, 3. Absolute minimum means the lowest point. Now there is no one point that is the lowest because it goes down forever, so that's why there's none for that. And then our increasing, decreasing. So we are increasing to begin with, so it's increasing from x values between -infinity and -2. It increases from 0 to 2, the x values, and then it increases from 4 to 5. The decreasing, it decreases from the x values of -2 to 0, and then again it decreases from 2 to 4. All right, so you just double check what problems you have to do, but you also have to finish up page 13, and then page 14 and page 15. That's yours. Again, answer key will be posted for you. Enjoy. If you have questions, visit my office hours.